Hi everyone. Today you're going to be looking at the lesson 1.4 for solving inequalities. Our learning target today is that I can solve linear inequalities. Very similar to solving equations, but we don't have an equal sign. We have an inequality sign, so it is a little bit different. So some of the things you know that you need to do for this is you need to be able to distribute, combine like terms, use additive inverses and multiplicative inverses. Remember, inverse just means opposite, so it's the opposite of adding. It's the opposite of multiplying. And determine if the symbol needs to change. Like if it's a less than, does it need to change to a greater than, and why? So you'll need to fold this foldable in half, where the title, Solving Inequalities, is on the front, and where it says to glue this into your notebook should be on the back. So you're folding it in half because you will tape it into your journal when you're done. Okay. The first thing that I would like you to do is know how to read inequalities. So in this first one, these are already solved. These are answers. But how do we read that answer? Okay, so in this particular one, that symbol that you see between the x and the 10 is a less than symbol. And here's how I know. It kind of looks like an L that has been squished. Okay, so I write an L above it, so that means less than. So all values of x are less than 10. And so I'm going to highlight the word less than so that I remember which symbol it is. Okay. Now, if we're writing it backwards and the y, the variable, is on the right side, we always start that way. So we're always going to start with the y's, or in this case, we're going to say all values of y. All values of y are. Now this symbol also looks like a less than symbol, but it isn't because we are starting with the y on the right side, so it's actually the opposite. This is actually going to be greater than. -2. So keep in mind that even though those symbols are exactly the same, we always start reading them starting with the variable. So in the first one, we started with the x. In the second one, we started with the y. So go ahead and pause this video and try to fill in the rest of them, and then unpause it to check your answers. Okay, so please check your answers to make sure that they are correct. Most of the time we will see the variable on the left, like x equals, except x is less than 10. But if it is switched, that means what you're saying needs to be switched also. So x is less than 10 is how the first one reads, but the second one is y is greater than -2 because the y is on the right side, okay? So I did make a note on the right. The one that looks like an L is less than, a squished L, and the other one is greater than, unless the variable is on the right side, in which we have to read it that way. And notice the ones that have a line below them are less than or equal to, but we also have greater than or equal to, like this one, x is greater than or equal to -4. Now let's look at how to solve these equations. So open up your booklet, and we're going to go over here. We do have one thing we need to look at. When we look at a statement like this, we need to know, are these statements true? Starting out, 2 is greater than 1. True statement, right? But what would happen if we add things to both sides, if we subtract things to both sides? What about if we multiply or divide? Does that change it? Because before it was always equal. What you do to one side, you do to the other. Does that affect this? So let's start with adding. So if I add 2 to both sides, is the left side still greater than the right side? Okay, so we know that 2 is greater than 1. Is 4 greater than 3? Yes, so it's still a true statement. Now let's try subtracting and do the same thing. Okay, so we're going to subtract 4 from both sides. in this case. Or maybe we'll just use the same number to make it less confusing. I think that might be a better idea. So we added 2, now let's subtract 2. So 2 minus 2 is 0, and 1 minus 2 is negative 1. So the original statement we know is true, 2 is greater than 1. Is 0 greater than negative 1? It is. So also true. So we can add and subtract things from both sides, and it still is a true statement. But what happens when we multiply and divide? Let's find out. We're going to multiply both sides by negative 2. Well, we'll try 2 and then we'll try negative 2. Let's try 2, positive 2. So 4 is greater than 2. True story. But what if they were negative? What if I multiplied both sides by negative 2? We would get negative 4. Is negative 4 greater than negative 2? No, that's false. So to make it true, we would need to flip that inequality symbol, the greater than. And same thing goes for the next one. What if we divided both sides by 2? We would get 1 is greater than 0.5. That's true. But once again, what if they were negative? What if we were dividing both sides by negative 2? Negative 1 is not greater than negative 0.5. So it once again becomes false. So it looks like this is only happening when we have negatives. Okay? So we have a rule when we multiply or divide by a negative, we have to flip the symbol to make it true. Because if I just flipped this symbol, this greater than symbol right here, it would make it true. Negative 1 is less than negative 0.5, not greater than. So if I flip that symbol, it would make it true, and that's why we do that. So let's look at solving a few of the problems, okay? Now I'm going to have you try solving some yourself and graphing them on a number line. So we're going to start with the first one. To solve for f, we subtract 5 from both sides to get f alone. It's a very basic problem. 5 minus 5 is 0. The symbol stays the same because I didn't multiply or divide by a negative. Keep in mind, you want to keep this highlighted up here, this special case, so that we know to go back to it. Okay? 7 minus 5 is 2. So this is saying f is less than or equal to. Okay? Probably should have written that over here. My bad. So let's actually graph that. So this is 0. This is 1, 2, 3, etc. Negative 1, negative 2, negative 3. We would put a point. Since it is a less than or equal to, we would put a solid dot at 2. Solid dot. And it's saying less than. Less than would be going to the left. You can also look at the symbol itself. It looks like a little arrow pointing to the left. Okay? So go ahead and try and solve number 2 real quick. Now looking at this one, you'll notice that we multiplied both sides by 3 to get the dividing by 3 done. And I did not flip the symbol. This is a greater than or equal to symbol. And I didn't flip it. When do I flip it? Let's look back up here at the special case. We flip the inequality symbol when we multiply or divide by a negative. So if you have a highlighter in your bucket at your group, I would highlight that. Only when you multiply or divide by a negative number. It doesn't matter that our answer was negative 6. What matters is what did you multiply both sides by? In this case, we multiplied both sides by 3, positive 3. So the symbol did not flip. And since it does have the equal to bar underneath it, it is a solid dot. We are including negative 6 in our answer. And it went to the right because we wanted things that were greater than negative 6, which is to the right. So what I'd like you to do is take a moment to try and solve numbers 3 and 4. Pause the video, and then you can unpause it when you're done to check your answers. Take a moment to notice the difference between number 3 and 4. Really think about What happened? What are the differences between the two? Because we basically got the same answer in the same graph. But the symbols were different at the beginning. So in number 3, notice we divided both sides by -4 because that is what is in front of the D. And we got D is greater than instead of less than 2. Because remember, we talked about if we divided or multiplied by a negative number, in this case we're dividing by a negative number, then the symbol needs to flip. So now it is greater than, and remember, you can treat this greater than symbol as like an arrow. And it's pointing you in the direction you should graph on the number line. So sometimes I draw like a little line there to show the direction like it is an arrow. Okay. And also notice that it is an open circle. I did not color in the circle that's on the graph. That's because 2 is not part of the answer. Remember, how would we read this? We would read it as all values or all values of D are greater than 2. 2 is not part of the answer. Okay? So if 2 is not part of the answer, then it gets an open circle. Only things that are greater than 2. And same thing goes for number 4. Since we did not divide by a negative, our symbol stayed the same, and it also came out to be all values greater than 2. Now take a moment and look at the right side of your notes and give a few of those a practice. And pause the video, and I will reveal the answers in just a moment. If you couldn't hear that because of the bell, you are working on questions 5, 6, 7, and 8 because we do know how to solve equations, right? It's just like solving an equation, except sometimes you might need to flip the symbol. So try solving 5, 6, 7, 8 and graphing them on the number line and writing a verbal description of your answer. Let's start at the top. We're going to review these pretty quickly. Make sure that your solving part is correct. And notice that in example 5 that the symbol did flip because we divided both sides by -3. So we get that our values should all be greater than or equal to -5. Notice that on my number line, I didn't include every single number because it didn't fit for me. But if you want to write all the numbers in between, you can. Like -2, -3, -4 are all missing on the number line. You can add them if you wish. Check out number 6. Okay, it is easier, I noticed, to try and eliminate the X that is on the right side so that you always end up with your X on the left because it is easier to read that way. And in this one, I did not need to flip the symbol because I did not divide or multiply both sides by a negative number. We got X is less than or equal to -6, so I had a closed dot because -6 is part of the solution. The solution is every number less than or equal to -6. Number 7, not too many errors here. I didn't have to flip anything either. So I have an open circle because it's only numbers greater than 6. So 6 is not included. That's why the dot is not closed. Only values bigger than 6. 6.1, 6.2, 8, a million, anything bigger than 6. The last one, there was a small typo. Please note I changed them both to X's because it did get confusing because there was an M there by accident. Please put an X. So look at that. Hopefully you distributed correctly. -3 times X is -3X. -3 times -1 is a positive +3. I combined those like terms to get 12. And yes, I did end up getting a decimal answer, you'll notice. And I had to flip the symbol. This one had many steps to it. So please look through each of the steps carefully. And if you had questions about any of the steps on these 4 questions, you need to raise your hand. You'll notice also I changed my scale on my graph. It went by 0.2s. So 13.4, 13.6, 13.8, 14, 14.2, 14.4, 14.6, etc. Okay? Make sure you're going the correct direction. And our inequality symbols are like arrows that tell us which direction to go. If you have questions about anything in these notes, let me know. Tape or glue this into your journal and start the Delta Math practice. It's either a Delta Math practice or a practice in Eduphoria Aware. I have posted them for you to practice while I am out tomorrow. Thanks, guys. Have a great day.